Much of our electricity comes from devices called generators. A generator takes mechanical energy and converts it to electrical energy by inducing electric current. That induced electric current is then carried to some kind of storage device, like a battery. If you opened up a generator and looked inside, you would see a coil of wire, and then you would see a rotating magnet inside the coil of wire. The coil of wire stays in place, so it is called the stator, Stator. The rotating magnet rotates, that's called the rotor, Rotor. Motors and generators both include stators, the stationary parts, and rotors, the rotating parts. In motors work in a very similar way, except instead of having a rotating magnetic field induce a current, you have a current that's supplied to the motor that then causes the rotor to turn. A generator, as I said, converts mechanical energy into electrical energy. So anytime you have a generator, you have to have some source of mechanical energy. The motion in a generator, it doesn't have to be circular, as we saw in Faraday's initial experiments. You really only need a changing magnetic field. So you can have a magnetic field that moves back and forth. For example, a bar magnet moving in and out of a coil of wire, or you can have an electromagnet that is turned on or off. Of course, an electromagnet is not an efficient way to produce electricity because it takes electricity to run an electromagnet. So there are different ways that you could generate electricity in a coil of copper wire. If you are going to generate some usable amount of electricity, you're going to want to have a lot of repetition. And so rotation is a pretty easy way to sustain the motion of your magnetic field or the changing of your magnetic field, but you can also have oscillation or moving back and forth.